Section 5.1, problem number 57, we need to verify this identity. And like the last few problems, I'm going to use the strategy of starting to try to simplify simplify the more complex side and see if we can kind of reduce it down to what's on the right or what's on the other side, the more complicated side. In this case, again, like the other ones, the left side is more complicated. So I'm going to work on just the left side here and try to make it look like the right side. And I can see on the left side I have powers of 4 and powers of 3, but the same sines and cosines. Excuse me. And on the right side I have a single power of 1. So I'm going to use factoring techniques to reduce down those powers. So I'm going to, in fact, identify them because these come up pretty often. So in the numerator, I'm going to use a difference of squares to try to get that to reduce down to sine x minus cosine x. And in the denominator, I'm going to use the factoring technique, sum of cubes. So these are two factoring techniques that I'm going to use in this one to try to reduce it down to single powers. So I guess I could do those in different colors. So let's do that. So let's do that in different colors. So the numerator, we're going to do the difference of squares. So looking just at the left side here, looking at just the numerator first, I'm going to try to do a difference of squares, which gives me sine squared x minus cosine squared x and sine squared x plus cosine squared x. And I can even take that a step further. I'll leave some space for the denominator to do in a few minutes. But I'm going to take that a step further and say that sine squared x, this is still a difference of two squares, so I can do sine of x minus cosine of x and sine of x plus cosine of x. And this guy is just equal to 1. So I don't really even need to write that one. Now for the denominator, so now I have my numerator down to single power of 1. So let's do the same thing with the denominator now. The denominator is a sum of cubes. So I can use the factoring technique there. Let's get my fraction bar here. And this can factor into sine of x plus cosine of x times sine squared of x minus sine of x times cosine of x plus cosine squared of x. I know this one we don't use as often as that difference of squares, so it might feel less familiar. I do have the factoring flowchart part posted somewhere, so that's a good thing to kind of keep near you to kind of remind you of those abbreviated factoring techniques that we can use. That's a good thing to keep with your bank. Okay, and then I'm just going to keep going with the denominator, and I can reduce it further. Let's see. I'm not going to change the first part, so I'll just copy that down. But the second part, I can see that, I don't want to use blue again, purple. Sine squared x plus cosine squared x can give me 1. And then I'll copy down the rest. Okay, so it's starting to look a lot more like the right side. So in purple there, we used the Pythagorean identity. So use identities. Looking a lot like the right side now. I see I have some things that can cancel. This is equal to this, and these are all factors now, so I can cancel those two things. And then I'm left with sine x minus cosine x in the numerator and 1 minus sine x cosine x in the denominator, which is equal to our right side. So that was my goal, to get to be like that. This now equals the right side. We started with the left side and we manipulated it till we got to equal the right side, and now that identity is verified.